Recording. All right, welcome back. It's 11 o'clock on Wednesday, so we'll just kind of get going. And I guess first, are there any questions? Anybody have any questions about what we went over yesterday? Any issues getting the labs purchased or set up? Okay. All right. Oh, good. The extension on Chrome, sure. The Proctorio, yeah. What's your question? Is it an exam or a testing of the app? The extension, I guess, the extension is used to access the exams, right? So it's the proctor. And I moved the practice quiz to week 2. So it's now due week 2. So if we go to week 2's folder, assignments, labs, discussions, the Proctorio check quiz is due week 2 and instead of this week. And so you use this Get Proctorio to install it, and then it monitors you while you're doing exams. But this is just a quiz. Yeah, it's just 3 easy, simple questions. Can you see the question, and just a little bit about yourself. It has real questions on chapter 1. The quiz. The quiz has real questions, but you don't need the Chrome extension to do quizzes, just the exams. So if you go to week 1, yeah, this chapter 1 quiz. It does not require the Proctorio extensions, and it doesn't need you don't need a webcam or anything. Only for exams. When you go to do the exam in week 4, so week 4 we have the exam. So this is when you need Proctorio and for the exam. So you see this secure proctor icon here. This means that you have to have Proctorio running in order for you to access and gain access into the exam and do the questions, but it's only on exams. Quizzes, you don't need the Proctorio. Yeah, sure. No worries. All right, great question. So what we have due this week is just try to get your lab access set up and going, because it's due next week. You have to do a lab next week. So please try to get this set up, purchased and set up this week. The introductions are due this week, and then just the chapter 1 post is due this week. All right. There's no other questions. We'll go ahead and continue with the chapter presentation. So let me get my phone, because once I do the presenting mode in this, then I can't see your questions. So I'll bring up bring up this Teams here and Teams. Okay, perfect. All right, okay. So yesterday we left off here on this image here or map. It's also in the book on page 12 that has this in a little better blown up, I guess, is what I want to say. So you might be able to read it a little better. It's page 12 in our book. But this is just saying that you have a threat, which is potential theft, right? You have the threat actor, which is this I'm a hacker, the hacker, and then you have vulnerability, which is they're saying is the buffer overflow in online database, basically for the web interface, so the web page is vulnerable, has a vulnerability. And then the exploit is someone's written a script that can create a buffer overflow on the website. So that's the exploit. And then the attack is when the hacker downloads the scripts and runs the script against the website and steals the customer data, which that's the customer database is the asset. So that's kind of the whole cycle of attack and exploit. But knowing the difference between what is a threat, a vulnerability, and an exploit, knowing those differences, right? So the threat is a potential theft, right? The vulnerability is that you have a buffer overflow possibility in the database, so that's the vulnerability. And then the exploit is being able to actually take advantage of that vulnerability. And then the attack is actually using the exploit to gain access to the asset. All right. So our information, right, has different values and characteristics, right? So the availability to our information, who has access, who needs access, and can they access it? It's available, right? It's available to them. Accuracy, the information is free from mistake or error and having value that the end users expect. Authenticity, right? So it's genuine or it's original rather than a reproduction or fabrication. Confidentiality, the quality or state of preventing disclosure or exposure to unauthorized individuals, right? To keep it private. Integrity, this is, it's whole, it's complete, it's uncorrupted. So the information is not exposed to corruption, damage, or destruction, and it's in its authentic state. Utility, right? So it has some value, right? Proposed or end, the value, it serves a particular purpose. It means the information is available, but in a format that the end user finds meaningful, right? It's got to be useful. Possession, basically ownership or control of the object, right, or information. This is McCummer's cube, right? So it highlights the fundamental approach of the whole chapter, right? The whole overarching theme in this chapter can be summarized here in this cube, right? So you have it illustrates the intersection between the x-axis, which is the information stage, storage, processing, transmission, with the key objectives of CIA, the confidentiality, integrity, availability, using the three primary means to implement, which is policy, education, and technology. And so it creates that 3D cube based on all 9 of these attributes, right? And where are you? What are you talking about? You know, are you talking about storage availability or storage integrity? Are you going to do education or you know, maybe some technology? You got some, you know, controls that you can implement through technology to prevent data corruption. You know, that's just a, you know, one way of using this cube. All right. So, and then of course, information systems are, you know, a set of people's procedures and technology that enable business to use information, right? It's just the sum of everything: the software, hardware, data, people, procedures, networks, right? That's our information systems. All right. And then this goes back to what I was saying yesterday, right? It's impossible to, you know, obtain perfection, right? You know, to you know, security is not absolute. It's a process, not a goal, and should consider balance between protection and availability, right? And the level of security must be reasonable, yet protect against threats. You know, like yesterday I talked about, you know, the only secure server is one where you know, dig a 50-foot hole, throw the server in, and fill it with concrete, right? I mean, but it's not very useful. So we need to find that balance, the need for security with business and to be able to produce value. You know, as a security analyst, I never tried to focus on saying no, like so many security analysts did. But I always looked at how can we enable the business and still be secure. That's somebody trying to get in. Let's see here. Okay, you got them in. Okay. All right. And then, so I never tried to focus on saying no, but there were times I still did have to say no, right? But when I, you know, came up with no's, you know, we can't do it that way, but we could do this, or this, right? I usually had options available to enable the business. I wasn't trying to, you know, because a lot of security analysts will just say no and not give any alternatives or options for the business to succeed and enable the business. And so it's just definitely not the approach that you need to take. It's not a good way to make friends in the workplace. But I mean, as a security analyst, you don't really need friends either. You do need to make it secure. But there are ways to make it secure and meet the business need. There's almost always a way that you can get something to work. So taking the, you know, approach of not saying no, but well, how can we enable this? And the book here discusses about 2 approaches to implementing security. The first approach they call the bottom-up approach, and that's where you have your experts at the front line pushing up security changes. The good advantage is they're experts. They really know what they're doing. They know the technology. But unfortunately, this approach doesn't work as well because it lacks some critical features, which is basically buy-in and management support is really hard. And so without the buy-in and management support, the funding is hard to obtain, and it's hard to enforce and ensure that other areas are implementing the security versus the top-down approach, which is initiated by upper management, right? They They issue policies, procedures, and processes, dictate the goals, the expected outcomes, and determine who's accountable for each of the required actions. So because of the stronger upper management support, right, you have dedicated funding, clear planning, opportunity to influence organizational change and culture. So it is a much easier process and more likely to succeed in most organizations. And it is most successful versus the bottom-up approach. And this is just a graphical representation. The top-down approach. You start at the CEO, or hopefully at CEO level, and you push down. Okay. All right. And then the bottom-up approach is where it might be coming from the network techs or the security analysts themselves and pushing up the organization. And so you can see why it's not as likely to succeed coming up, because to get the other areas to buy in on it, you need management support. And so it's not that it's impossible, but it's more challenging to do a bottom-up approach. Then we have what's known as the System Development Life Cycle, or SDLC, right? It's just a methodology or a way of implementing information system. It's a formal approach. It's based on solving a problem with set structure, a sequence of our procedures. It's a rigorous process, and it hopefully increases the probability of success. Traditionally, there's 6 phases, and here are the phases, right? So you got the investigation phase, analysis phase, logical design, physical design, implementation, and maintenance and change. And as you can see how the way they've depicted it, it flows down, and this is typically known as a waterfall approach. And in a true waterfall approach, you do everything in the investigation stage, and then you move to the analysis stage, and then to the logical design, and so you've progressed down. Contrast this with an agile approach. You may do all of these in a modified agile approach, but the difference will be the scope. So in a traditional waterfall implementation, the project will do the whole application, every facet, every web page, every server, everything will be done in the investigation stage, the analysis phase, the design phase, the implementation phase, the change phase. Where in an agile approach, you may just look at the functionality on one web page and go through all 6 of these areas, and then you finish that, and then you look at the next functionality and go through the 6. And then eventually, after you've gone through this 1,000 different times, then you finally have the application. Whereas with a traditional waterfall, you don't move to the next phase until all of the application has been designed and gone through this whole phase, through that phase. So that's kind of the difference between a waterfall and agile, and the book didn't really cover agile, but agile is more popular and definitely in the software design stage now. So I felt that you should at least get some mention of agile here. So then we're going to talk about each of the phases, right? So the investigation phase, right? We're just trying to investigate what's the problem we're trying to solve. What are the objectives, constraints, scope. So do we need the application to do X, Y, and Z, but not do A, right? Some kind of things. So maybe you're looking at a accounting program, and you want to be able to do all your budgeting and all your reconciliations and things like that in your application, but you don't want it to be able to maybe issue checks. You know, that's a constraint, right? You know, and that's a scope. You're only looking at doing, you know, the budgeting aspect of the accounting app or something like that, because that's something you can push out in the next 6 months, right? Whereas if you had to do checks and everything, that might add another 6 months and another couple $1 million to the project. So it's out of scope, right? So, but that's your investigation stage. You know, what are you trying to achieve? You know, what's the cost benefit, you know, for doing so? Because when you're looking at a project, it's not just, you know, oh, well, we want to do this. We need a new budgeting app. You know, but what's it going to do? Is it going to save time? Is it going to save money? You know, why? You know, we're not just going to implement something just because we can, right? What's the cost? What's the benefit? You know, and it's, you know, it needs to tip the scales to where you're going to get more benefit than the cost of doing this. And then, you know, at the end of all phases, you know, you assess the economic, technical, and behavioral feasibilities and ensure implementation is worth the time and effort. Like I say, you just need to justify it and then get approval to proceed, right? This makes sense so far. Then we go to the analysis phase. So then we're doing a little bit more investigation and the assessment of the organization. You know, where's our current systems? What's the capability to support the proposed system? You know, do we need to stand up a new team? You know, so that's, you know, a lot of the projects that I got involved in. It was determined that a whole new team, a new support team, needed to be set up because there just was no team in the existing organization that fit the criteria. So we needed another, you know, a new team to support whatever functionality we were adding or bringing in. You know, like one of the systems I brought in was the language translation system. So there was a system that would help translators translate. And so we created a whole new team, you know, for the translators to be on, as well as the technical team to support this application and get knowledge on this, because it was just so different from anything we did in the organization. I'm sorry. And then, but so you have to look at the existing organization structure and what's going on, what capabilities do we need, who can support this, and then how's it going to interact, you know, and so that's kind of done at the high level here, the analysis phase. Hopefully, you know, you're still doing high level. You really haven't gotten into the details. It's just, you know, okay, if we do this, you know, do we have the personnel? Do we have the capability? What systems would it interact with? How would it work, right? At a high level. Then we move to that logical design, right? And so this is, you know, taking in the business need again. You know, we're looking at the services that it provides, and then we're looking at now a little bit more technical as to, you know, any data and technologies or any you know, that are actually needed. So do we need a SQL server, or do we need Oracle, or, you know, and we're going to probably come up with several possible solutions to implement this project, right? So that we have we can do a cost benefits analysis and determine between these options, you know, because there's usually multiple ways that you can implement a system, right? And so maybe you're going to be using Linux front ends with a Windows back end, or Windows front end with Linux back ends, or all Linux, right? It really, maybe you're going to do your front end is going to be in the cloud, but your back end is going to be in your data center. And so you need to make those determinations, but you have to have several options, right? And then you weigh the pros and cons, the cost benefit analysis of these different options, right? How, what's the best one that fits our organization at this time with our resources, right? And then this is one of the areas too that a lot of areas and businesses fail to really document why they chose what they did and how they came to that, because then 3 years later you come back up and you're reproducing a lot of the same things, or somebody say, well, why aren't we using this on Oracle? And it's because XYZ app can't use Oracle database or something, and you found that out, but that gets lost. And you seem to, I saw a lot where you redo this logical design multiple times, and you fight the same battles over and over, because that historical information tends to get lost in the shuffle. But as long as you're still doing the logical design process correctly and weighing the benefits and costs analysis, it's fine, but I hate to see the rework. You're doing a lot of rework sometimes to come up with the same solution or same decision. But you have to at least weigh it out, because things change, and there may be maybe the XYZ app now supports Oracle, and so now it's an option that fits better, right? Then you go to the physical design. So now we've went the benefits, cost analysis, pros and cons of different solutions, and we've kind of picked one, and now we're actually going and getting, we've selected the technology, what stack we're using, what are we going to actually build, and now we need to design it out, right? So then what components are needed? Do we make them or do we buy them, right? So do we actually create the code and create the software, or is there existing software that we can buy off the shelf, and configure our own, to our needs, right? So, the make versus buy decision is handled here, and then we need to design out at a high level what that solution is with that particular technology stack. So then this is feasibility analysis is performed. How realistic is it? How long will it take? How much will it cost? And is this something that management wants to sign off for? Because once again, you could determine, okay, this is going to be a 3-year, $15 million project. And then management looks at it and says, no, we don't have the time and resources for this, because we've got project 2022 that's going on right now. We need the resources for that, right? And so, but you at least put it all together, you package it together. This is best case, what we're thinking. And then you go up for management approval from the designs. And so also, you've hopefully they've taken advantage of security areas to review some of the high-level designs and sign-offs that, yes, this is something that's going to be approved in your organization too. This is where getting security involved earlier versus later is always best. It never failed, though, as a security analyst, I would be brought on to a project that was actually past this stage, and they were trying to go, which is implementation is next, and they're in the testing phase and things aren't working. And I get brought in and I look at it right away and it's like, well, you're using this completely wrong. There's no way this is going to work in our environment. Why didn't you get security involved earlier? We don't allow this, it's not even possible. It's just not possible to do what you're doing, and we have to rechange the whole physical design and go and get a change request approved from upper management because security-wise, it's just not even feasible. So hopefully the project is getting security buy-in and consulting during this phase before management approval gets done. But not everyone does that. A lot of them see security as derailing projects, and so they'll try to avoid getting security involved until things don't work, and that's a bad approach. All right, so then next, after we get a management approval for the physical design, we get into the implementation phase, but this is actually also the testing, right? So we're actually developing and testing, you should be putting this in a test environment and building it out, testing it out, and then you go, you get approval once you get some performance reviews, acceptance testing, are done, then you get approval to go actually into production and implementation into production. So it's kind of weird in this phase. There's actually this phase here gets broken down into phases in most organizations, where you'll have your development, you'll have your systems testing, and then maybe even a simulated production, and then the actual production. So you may actually go through 4 different gates here of approval processes in the implementation phase of the project. But you definitely should be doing a performance review and acceptance testing for any major changes, for sure. But when you get into the agile environments, you still have some testing, but they move a little faster, and they cut a lot of corners sometimes. And so depending on the organization, they may not be as rigorous, but they do still have to do some testing. There's just no way you can't get around not testing outside of production. It's just a bad practice. But then once you've actually implemented a solution, you have your maintenance and change phase. This is the longest and most expensive phase to maintain your systems. So so maybe it took you 3 years and $15 million to implement a solution, but it may run for 10 years or so, and the support costs could be another 20 million or whatever. You never know, but it will typically be your most expensive and longest phase. And then of course this consists of all the support and throughout that life cycle. While you have it in there, this includes the help desk, teams that support the servers, the database analysts. Then when you get security patches and updates, changes, service packs, vendors. Maybe you have part of your solution is a vendor application, and they have updates or security updates. So those all get put in there. But hopefully you have some kind of formal change process where you're putting these changes in a test environment, testing them out, checking them, and then pushing them to production. But so, like I said, that support structure is very similar to the implementation, but it's ongoing for the entire time for that app or systems that are in place. And then once it's no longer needed, then you have to decommission it and remove it from your support cycle. And so that's updating the help desk, updating server and hardware, software inventory lists and things like that. There's a lot to decommission a system. It's a very almost a mini project in of itself to actually remove a system from an organization. All right, software assurance. So most organizations know they have to plan for security in their life cycle, right? They need to establish procedures to create software more capable of being deployed in a secure fashion. This approach is known as software assurance. And then software assurance results in the publication of secure software assurance common body of knowledge, or CBKs, right? So you're just trying to make sure that you're deploying secure solutions into your organization. And this process is known as software assurance. And then, so the U.S. Department of Defense and Homeland Security, they have an initiative, right? And then this software assurance common body of knowledge is a work in progress and contains the following sections: natures of dangers, fundamental concepts and principles, ethics, laws, and governance, right? We got a ton of them here, right? So there's the requirements, design, construction, verification, validation. So so that's really these requirements, designs, constructions, verification, validation, evaluations. Those processes are really what I would call part of your implementation phase, because you're gathering your software requirements. What does the software need? You're designing the actual software, coding it up. Construction is finalizing the code, and then you verify and validate and evaluate and test the code, right? So that's where those are. Then you have secure software tools and methods. How are you going to test it? What tools do you use? What processes and procedures do you use? How do you run a software project, right? That project management, acquisition of secure software. If you have to buy stuff off the shelf, right, or from a vendor, what's that process look like? Secure software sustainment, how do you sustain it? How do you keep it secure? So then we have the software design principles, right? So first one is KISS, right? Keep it simple and small, right? You want fewer lines of code, less complex code. It's easier to maintain. It's easier. It's quicker to develop and deploy, and definitely it's easier to troubleshoot. In a lot of the environments I was in, our complexity was the size, right? Because you're dealing with something that had to handle millions of customers, right? So you didn't want anything over complex. You needed to run fast, you needed to run quick, but you needed to run. And then if there was a problem, you needed to troubleshoot it really quickly. So you kept the design simple and small. Access, right, is granted by permission, not exclusion, right? So you purposely give this group of users permission to read, right? You don't give them, give every user admin, and then you limit on some things and take away and say deny user Bob on this, right? You don't do that. That's a bad design. You give access by permission and only the rights that they need, right? And then authority is checked for all access. So when you go to access an object, access is checked at the access of that object. Then you have possession of keys and passwords, right? So you definitely have to have keys and passwords, and you have to have them but then how you put them in, right? Some of the secure designs call for getting the passwords and keys at runtime, right? So we developed, we were one of the first few to do this, because it just wasn't a thing. But being able to at runtime have the actual app call out, query a database, and get its password, and access its password on the fly instead of hard coding the passwords and keys in the code. That's very bad if you have it hard coded in the code. It should have some kind of access rights, and but you should have possession of them. And protection, should require 2 keys to unlock, so multi-factor, right? You should it should have multi-factor mechanisms in place. It's ideal. And then the least privilege approach. You only give what is necessary and needed, give the least amount of access to perform their task. In other words, don't grant a user admin rights when read access is all they need, right? It's known as the least privilege approach. All right, and then we minimize shared mechanisms, right? Make the interface easy to use as designed so users do not try to circumvent the process and built-in security. All right, NIST is a government body. They're very good at publishing all kinds of information security related. If you're working for the government, you're required to utilize a lot of NIST documentations. But this NIST publication 800-64, revision 2, right, maintains the early integration of security in the SDL and enables agencies to maximize return on investment, right? So it allows you to figure out how to put security into your processes. It's a documentation that steps through what you should be doing, how to identify and mitigate security vulnerabilities, misconfigurations, awareness of potential engineering challenges, identification of shared security services and reuse of security, and facilitation of informed executive decision making. So it's this document that helps you make better code and have better projects, more secure projects. And then the NIST approach with initiation, right? So security at this point is looked at in terms of business risk, with Information Security Office providing input. Key security activities would include delineation of business requirements in terms of confidentiality, integrity, and availability. See how it, CIA, it's that cornerstone. Determination of information categorization and information of known special handling requirements to transmit, store, or create information, and determination of any privacy requirements. So that's definitely a big issue in today's world, keeping the information private and what kind of information that you have. In fact, my wife, she, her entire job is just to going through all the documents that were breached in an incident, and that's what she does all day, is go through and determine what private information was leaked during a breach. That's her entire job. I mean, she runs teams that do this, and they do hundreds of thousands of documents that were in a breach. It's just it's mind blowing. The number of projects she's on, and she's just one of many that multiple projects that this law firm deals with. But it's just scary. But this determinant of the privacy requirements, fits in there. That's all right. So this is showing that initiation phase. If you want to get a better look, there's a better picture on page 33 in your book. It's a little easier to read than this. But this is, how you should determine to do a project or not. Should you develop or buy? So you've got that initial security planning. That's that big box there in the top center. And so your security planning, then your categorizing information systems, you go down, right? It's a high level securities requirements, right? That's your outputs out of that categorized information system. And then you've got two flows, right? So you do the asset business impact on the left, and that's, looking at your business drivers, your core system components, your recovery times, recovery point objectives, right? How long can you be down? What's the point that you would be recovered, and so that's that business impact analysis. If this goes down, how many millions of dollars would it cost, right? Per day, per week, or what's that business impact? And then on the right side, you do the same thing, but you're assessing privacy impact. If there was a breach, what kind of cost to your reputation? What kind of financial costs are we looking at? And what does it do, to our reputation as far as being a trusted source for our customers, right? If we lose that information, and so then you get the results from both the business impact and the privacy impact, and then you go into the ensure secure system development, right? And this is security training for development teams, quality assurance, dev and coding standards. That's what's going to be found in here, right? Because you're going to have a lot of reusable code, hopefully, that's been developed, vetted, and known to be secure. So that your developers can reuse and leverage existing code, and then you get to the control gates, right? So once you've got that, it's the acquisition strategy, system concept review, performance specs, your review, your financial review, financial risk management. And then this is like, okay, so we've got all this in place and we got the business impact, we've got the privacy impact, we've got some good coding practices established and rigor. Let's go and yes, we're going on and decision to begin the development or acquisition. So we're going to go on. And so then now we're into the development acquisition phase. We're conducting risk assessments and use results to supplement baseline security controls, analyze security requirements, right? Do we have to encrypt traffic at rest? Do we have to encrypt it in transit? What kind of requirements do we have? Are they regulatory, legal, in some nature? Do we, are we obligated by some organization like PCI, which is the payment card industry? So if we take credit cards, there's a whole list of security requirements that your organization would be required to meet for certain applications and systems that deal with credit cards. Maybe you're a publicly traded company, and then so Sarbanes-Oxley or SOX might apply, and it has all kinds of security requirements that are put in place. Maybe you're a health hospital or something like that, and HIPAA applies because you're dealing with health records and information. So what are the security requirements? What do they pertain to this development and acquisition? And then you're going to perform functional and security testing, prepare initial documents for system certification and accreditation. So you're usually going to have your system certified by technical experts in their fields, in their areas. You'll have a government's body, typically in a larger organization. You'll have an organizational body of analysts, and their job is to look and review at your coding and your solutions, and then they certify the solution and say, yes, you're following all of our policies and procedures. You're following the guidelines. You're encrypting traffic. You're following the laws in that area. But and depending on the organization. So I worked in several large organizations, right? And you might have 50 to 100 different people with their expertise areas that certify a project, right? And you got to go through all 50 gatekeepers or 100 gatekeepers that review your plans and your development to get your security certification. And then you're designing the security architecture as well, which is part of that certification process, right? That overarching, and this a lot of time is just a certification that yes, you can continue and go and develop it. you get your plans and everything, your architecture scoped out, and then they approve you to develop it, and then they approve to go into implementation. So you have several processes. And then here is the workflow of that development acquisition phase. Again, this is in your book. It's a little easier to read at page 34. And so now we're actually doing the project, right? We've got the plan, we've got the design, and you're starting with the risk assessment, and so this hopefully, it's like the business business impact analysis, but this is just that overall risk. What risk does this solution introduce to the organization, and what kind of mitigations can we put in place to limit those risks, right? And then we're going to select the documents security controls. So we're doing the security plan. What kind of controls are we going to put in place to help mitigate these risks? And then you go to the design secured architecture, right? So what shared services, what shared risks, are we using? The schema of our security integration. So how does it integrate with other security solutions that are already there? Our ID, your identification of common controls, right? So that you might be leveraging some controls like login, right? You're not probably going to reinvent the login process. You're going to reuse the login process that's already been built for other applications and systems. So you're going to leverage that common control, right? But what are they, and how are you leveraging them? Then we're going to engineer in security and develop the controls. So any controls that we need that aren't common, right? So what do we need to set up and develop? And so we're going to get our specs. We're going to plan it. We're test it, and check them out, right? And then of course we're going to do the development security documentation. You need to document what you're doing, right? Because you're developing new controls. So other areas and projects in the future are probably going to utilize your security solution. plus also those that are going to need to be able to troubleshoot your security solution. They're going to need the documentation of what did you do, how did we do it, why did we do it, right? And then conduct our testing, and then we're going to go on to our implementation phase. But we got some gates, control gates again, right? So we're going to have an architecture design review, a performance review, functional testing review, right? Does it do what it's supposed to do? We'll have a risk management review, and then possibly even a mid-project status review and financial review at this point, right? So I'm sure the project manager is going to be reporting up to management. Here's what it actually cost versus what we thought it was going to cost to get us to this point. But right now we've got a developed solution and it's been tested, and we're now ready to implement. And once again, this is using the NIST process. All right, and then so system install and evaluated in operational environment. So our key activities would be integrate the system into our environment. We're going to conduct system certification activities in conjunction with testing of our security controls and complete system accreditation activities. And here's the diagram, page 35 of your book, if you want to follow along. It's a little easier to read maybe. But so we're actually implementing the solution. So we create a detailed plan for certification and accreditation, the CNA, right? And part of that is our initial work plan. So how are we going to do this? You know, are we going to roll out simultaneously to all environments, or maybe we're going to do, East Coast, then Central, and then West Coast, or maybe we're going to do U.S., then Europe, then Asia, right? You know, how are we going to roll this out? And what's our work plan? And then we're going to integrate security into environments or systems. So we're actually going to take and operationalize our security controls and complete system documentation, right? We're actually integrating it into the environment. We're going to assess the system security. We're going to do a security assessment report, the input for the plan of actions and milestones, right? So the POA and M. Documentation updates, security authorization package, which leads us to the authorized information system. So the security authorization decision, the final security authorization package. I mean, this is final sign off that everything is good, it's golden, it's in place, and we're happy, right? So the control gates to get through this phase, right? So the system test readiness review, deployment readiness review, the certification and accreditation certification, review. So the authorization decision, final project status, and the financial review, the final financial review, and then the IT deployment or connection approval would happen here too as well. All your final checkoffs, right? All the final approvals, everything is documented. You're storing all your documentation as well in some locations so that it can be used by the next effort, or anybody that needed any historical information as well. So that's what's going to happen. And then that's moving us into the operations and maintenance phase, right? So it's live. We're running. Now we got the support team, right? Systems are in place, but you may need to do modifications in the future. How are they developed, tested? How are they hardware, software added or replaced, right? So this is that operations and maintenance phase. So you'll conduct readiness reviews. You'll manage the configuration of the system. So you'll have a system configuration and and any change to that configuration will have to go through a change process, right? Hopefully you'll have a formal change process to manage that configuration and prevent changes from going in without some kind of oversight, and then you're going to institute process and procedures for assuring the operations and continuous monitoring of the information system security controls, right? So your system's going to produce probably a wealth of logs and messages and that need to be monitored, examined, analyzed, and maintained to be able to maintain that system. So you got to have a process and procedure on how to handle those. And then performing reauthorization as required. That's that change control process. If you need to make substantial changes, you might even have to kick off a project. Certain small changes like a security patch or something like that can usually just be done with what's called a change record. Very simple. You still go through a change review board or that. But anything major, like say an upgrade to the app, the app had a version change, that might require its own little reauthorization project and go through the whole phases to do the upgrade because it's a major substantial change. And here is the diagram of this phase, page 36 in our book, if you want to get a better picture of that. And so we're going to start off with the review of operational readiness, right? So looking at the security implications due to changes, perform any configuration management and control. So I have change control board decisions. As I said, update security documentation, security evaluations, right? So if you're making any changes, you need to update your documentation. Conduct continuous monitoring. Once again, the PO-A&M review, right? And results of continuous monitoring. Reviewed security authorization package, security reauthorization decisions. If you're changing anything, you've got to reauthorize it. And then some control gates are the operational readiness review, the POA&M review, and change control boards, authorization decisions. And then that goes up until the end of life, where we decide, do we need to dispose of it, right? So then we go into our disposal phase. So we create a disposal transition plan. We'll archive any critical information that may be useful for future, or maybe required. I mean, in certain instances, many of the stuff that I was dealing with, we had a legal requirement. We had to keep it for 35 years. The designs, everything, it was ridiculous, on certain of the projects, So it was like, it was silly, but we had to keep the software, the applications, the hardware, not the hardware, but the design plans. It's like in 35 years, nobody's going to be able to run this, but okay. But legally, we were required to have it for 35 years. So some of that, process you have to go through. Then sanitation of media, wiping the drives, disposing of the drives. Sorry. That's as long as my life. So 35 years. Yeah. No, I know it was ridiculous. It was just a ridiculous requirement, but legally, it was required. I was with you on that. It's like, yes, yeah, because a lot of times at the time I wasn't even 35. It's like, come on. But but yeah, so then disposal of the hardware and software, a lot of times it's not just simple to delete the data. In my organization, we would magnetically wipe and then grind the hard drives. They would be ground into chunks and then disposed of. But it all depends on what you're dealing with and what requirements you're held up to. But you have to follow those processes. And then here's the diagram picture of our disposal process, page 37 in our book. Right. So then you build and execute our disposal, our transition plan. You'll go to sanitizing our media, and then ensure the information preservation, disposal of hardware and software. Close the system, right? So you verify everything's been removed, deleted, archived, and some control gates would be some system closure review, a security review, and most likely a change control board review as well before it's actually said, okay, the system's gone. All right, so Microsoft's software development life cycle. So you have just another one where you got training, requirements, design, implementation, and verification. Pretty much the same. I'll go talk about the fuzzy testing since it's something that we really haven't done. Fuzzy testing is trying to put in things that you wouldn't think that people would do. So putting letters in for a credit card number, right? You're doing things off the wall, trying to break the system. You're doing things that you shouldn't be doing, and trying to see if you can get some kind of results, right? But otherwise, it's still, it's just different names for stuff we've talked about. The release and response. So a release is the whole going to production, right? So you're creating an incident response plan and conduct a final security review, certify the release, and then archive it. But it's just implementing that. A response is execute an incident response plan. So incidents, though, are typically considered, like a hacker hacking in or a denial of service. That those are typically an incident. But it could be just it's kind of hard because then in like the help desk world, an incident is just a normal ticket, right? Whereas in the security realm, an incident is some major event too. So it kind of gets confusing on what that word, what are we meaning, in what context are we talking? All right, so security professionals and the organizations, right? So it takes a wide range of professionals to support a diverse information security program, right? At the organization I was at, I was one of 200 security analysts, right? We had over 200 security analysts at the time that I was in security. And so a lot of them specialized, right? So we would have some mainframe security analysts, you'd have cryptographers, you'd have Active Directory security analysts, you had workstation analysts, server analysts. I was on the the web application development. So I automated security solutions as well as ran security projects. So I would be the lead security analyst, and I would be responsible for all the security analysts on a project. But my main skill was automating security solutions. So so it just takes a very, in the large organizations, for sure, you have a wide range of professionals. You know, a lot of the projects that I was on, we'd have 50 some technical analysts or more with various skills in certain areas performing the roles. So it does take a wide range of professionals. But then I worked at a school district, and you know, I had 7 techs, and we ran everything. We were responsible for everything. And so, I mean, that's a whole different scenario. But you know, so you can go from the small side to the large side, and you know, it'll definitely have a wide variety of range. But you know, but you still need to do create security policies, procedures, and additional administrative support and expertise is required, right? You definitely need to have some processes and procedures in place. You know, even at the school district, you know, I would document things as best I could, and we train everybody to do it the same way, right? Because you had to have some kind of procedures and process in place to ensure things got done the same way, right? And then you have senior management. In most organizations, right, you'll have a chief information officer. He'll be your senior technical person in the company. And then the CIO is primarily responsible for advising the chief executive office, or the CEO, the president, and preparing strategic planning that affects the management of information. Yep. And then you might have a chief information security officer, which then that would be the head security person in the company. So some organizations will have this, some won't. They'll just have the chief CIO. But if you have a CISO, then that individual is primarily responsible for the assessment, management, and implementation of securing the information within the organization. And you know, CISO might also be called the manager of security or security administrator or something like that. And they'll typically report to the CIO. So the CIO will report to the CEO, and the CISO or security manager, that will report to the CIO, depending, right? And you know, some may report to the CEO, but it just depends on the organization, and that'll depend on how things get driven and what kind of stance the security has within an organization. Because if you don't have some kind of upper level buy-in or management in the security realm, it's really hard to get security efforts through, and you know, it can be a challenge. Then you can have security project teams, right? So a lot of organizations, you might have security project teams and security service teams. A lot of times they're filled by the same people. Like in my organization, we both did service and project to some degree, or at least the team members did. But usually you were dedicated as service or project for certain time periods, and we would rotate through on that. And right, so then a project team is just, a number of individuals who are experienced in one or more multiple requirements, both technical and non-technical areas, right? You can have a champion, a senior executive who promotes the project, the team leader. Now, so you can have a project manager who leads the overall project. It could be a department line manager, staff manager, personnel management, something like that. But in a lot of cases, you'll have a lead technical analyst too. So I performed that role many times, where I wasn't the project manager. I wasn't really dealing with the budget per se or management, but I was dealing with all the technical personnel and managing what happened in testing and development, and the programmers, the developers, the testers, all of that. So I was the technical lead. But then you'll have security policy developers, those that understand the organizational culture, policies, requirements for developing. You'll have risk assessment specialists, right? So I would be part of a risk assessment as the lead security analyst on a project. I would be in the risk assessment. I would have a lot of the input into it, but we had risk assessment specialists that really understood the company, the financial risk, and the risk methodologies that would lead these risk assessments and help guide us through making the right decisions, and coming up with our true risk assessment of a project. Then, of course, you had security professionals. Like I said, if you were dealing with mainframe, you have mainframe analysts. If you're dealing with Windows, you'd have Windows security analysts. So you have different security professionals. Systems administrators, right? So maybe you're implementing an app with an Oracle system, and so you would have Oracle DBAs, system administrators that would be part of your project. They're responsible for administrating the systems in-house, right? The server, you'd have what we called them network operating system analysts, NOS analysts. They were responsible if it was a Linux box or a Windows box. They would be involved. And so you'd have that, and then you'd even have end users as part of the project team, for testing. So maybe say let's see, accounting. Accounting was wanting this new system. You would have accounting analysts, business analysts that would be using this system as part of the project team for testing and going through and talking to them and giving feedback to the project. But there would be business analysts that would typically be on there, and then and then in some cases, if you had customers, you would have. That's more rare, but you would have some, actual end users if you have, customers or whatever using and testing. But typically, not so much. But maybe the business area that's going to be using it, testing it as a user, right? And then data responsibilities. This is huge. Who owns the data, right? So members of senior management who are responsible for security. Data owners usually determine the level of data classification, as well as changes to the classification required by our organization. Data owners work with managers to oversee the day-to-day administration of the data, who gets access to the data, what levels of access, so that, they're responsible for the data, but really that's probably more of the data custodian as far as who gets access. But the data owners are responsible for the data at the end of the day, so they're the ones that make final approvals. But custodians are working directly with data owners. They're responsible for the information in the systems, the process, transmit and store it, depending on the size of the organization. It's maybe dedicated positions such as a CISO, or it may be an additional responsibility of a system administrator or a technology manager. And the duties of a data custodian often include overseeing data storage, backups, implementation of specific procedures, policies laid out, um, and security plans, and reporting to the data owner, right? And then you've got data users, right? So that's anyone that's, anyone and everyone that's using the data, right? So it's in an organization, it's everybody's responsible for the securing of data. And so data users are included here as individuals with an information security role. And we have as communities of interest, right? Each organization develops and maintains its own unique cultures and values, right? It has their own roles, their own processes, their own procedures. Within the corporate culture, there are communities of interest. These can include information security management and professionals, information technology management and professionals, organization management and professionals, right? So in larger organizations, they may even be broken down even further, right? Smaller organizations, they may all roll up into, that's Bob, right? So, it really just depends on the organization, but you're going to have, regardless, somewhere within that organization, these roles and that are going to, these communities of interest are going to apply. It may be a single person, but then again, it could be, multiple departments and multiple people. And then most important, information security is more an art than a science, probably in some aspects, right? With the level of complexity in today's information systems, implementation of information security has often been described as a combination of art and science, right? The concept of a security artisan is based on the way individuals perceive system technologies since computers became commonplace, right? It's not a one size fits all, right? Each organization is unique, and what one organization determines as secure, another organization may find totally inadequate, right? So there is some movement, and flow to security, and I would say that in a lot of essence, it is an art to some degree, but the strong argument is that, right, you do have to do certain things certain ways, right? If you're going to do an IPsec tunnel, these are the certain ways you're going to do an IPsec tunnel. But the fact that you're doing the IPsec tunnel versus some kind of other solution, or maybe just not encrypted at all, right? Those are choices that as a security analyst you're going to have to choose. And then, but right, so there are no hard and fast rules regulating the installation of various security mechanisms, nor are there many universally accepted complete solutions, right? Like I said, one organization may find it fine and another inadequate. While there are many manuals to support individual systems, once the systems are interconnected, there's no magic user manual for the security of the entire system. This is especially true with the complex levels of interaction between users, policies, and technology controls. And however, there are many regulations and requirements that organizations must adhere to. For example, encrypting personal information, which is called PII, while at rest or in transit is one requirement that many organizations must follow, right? So there are a lot of things that you have to do if that you're legally required to do, but then there's still a lot of room in how you actually do it, right? Yes, it has to be encrypted, but there are many different ways to encrypt it. Which solution do you use and choose, right? There is a lot of leeway. But then security as a science, right? We are dealing with technology developed by computer scientists and engineers, right? Technology is designed to perform at rigorous levels. Even with complexity of technology, most would agree that specific scientific conditions cause virtually all actions that occur in the computer systems. So almost every fault, security hole, and system malfunction is a result of the interaction of specific hardware and software. So if the developers supposedly if they have sufficient time, they could resolve and eliminate these faults. I would also go and argue if they have enough proper training, because a lot of times we don't train our developers adequately enough to develop secure code. I mean, we'll get into it a little further down, but a large lion's share of issues and breaches and things are caused by simple validation input verification that we don't really teach, or developers don't take the time to do because it's time consuming and cumbersome. But it kind of leads into if they had sufficient time, they could resolve and eliminate these faults. But however, so many security issues are also the result of just bad programming, results of ignoring industry best practices that we've known for decades, right? And like I said, the improper input validation is one of the more common issues that occurs. The OWASP, if anyone's heard of that, the Open Web Application Security project. It has a top 10 list, and then it's known, let me see here. Let me go ahead and stop this for a second here and just show you that. So this is OWASP, maybe. There we go. Wow. So their top 10 right now is injections, such as SQL, broker authentication, sensitive data exposure, XML, access control, security misconfigurations, cross-site scripting. Yeah, boss, thank you. Yeah. Insecure deserialization, using components with known vulnerabilities, and insufficient logging. So these are what they deem as the top 10 web issues, and they constantly update these. And it's good information. But I do highly recommend you taking a look at them. Thank you, Jacob, for putting the link in there. But yes, so. Like I said, a lot of these issues, we've been dealing with for decades, and if you go through a lot of the training at most universities, and what I've seen is we still teach coding the same way, and I get it that creating secure code takes time and is difficult, and you're just trying to teach people how to develop code, but the way that we teach it a lot of times is they're just teaching how to code, but not really taking into account any security at all, and really glossing over some of the more critical aspects. I think, at least that's my opinion. And if you do even connect into a database in the coding world, they very rarely use stored procedures or anything. They may see that as advanced or something like it, but I mean, it's just one way to prevent or to limit input issues. And so, I mean, that's just one big area that I don't think we do enough and don't stress enough in our development training. But all right. And then finally, security as a social science, right? This may be a third alternative view, right? So social science examines behaviors of individuals as they interact with systems, whether societal systems or, in our case, information systems. Security begins and ends with people, right? Inside the organization and out. And then the people that interact with the system are planned or otherwise. And we have end users that need the very information the security personnel are trying to protect, and maybe the weakest link in the security chain, right? By understanding some of the behavior aspects of organizational science and change management, security administrators can greatly reduce levels of risk, caused by end users, and create more acceptable and supportable security profiles. That's true, and you'll hear over and over in many security courses and training, right? People that's the biggest weakest link, right? In any environment, you can have the most secure system in the world, but if Bob gives out his password to somebody that comes in and acts like they're from IT, it doesn't matter what security you've put in place. They've just been granted access in, right? So your people are your weakest link in any organization, in any aspect of talking about security. So this security as a social science, it definitely resonates and has some traction, I think. So knowing people and how they interact and can help you be a better security analyst. Especially, you have people who certain security analysts, their job is to pretend to be a hacker, right? What is their motivation? How are they going to get in? How could they get in, right? So, that's all about this behavioral science and understanding of people, right? So it's a whole nother aspect of the security realm. But you have to have that first, the more scientific and base level understanding of security before you can move up to more of these behavioral change, because you need to have to understand how it is secured before you can see, well, how can you get around the security so that you can try to plug those holes. All right, so that is chapter 1. So I appreciate your time with me this afternoon. Any questions over chapter 1? Anything that, besides having to keep things longer than you've been alive for some things, and there's some machines too. I forgot to even mention that. I believe my organization still has a machine, because I was had a machine during this operation during some legal action, and all our machines got collected for review, and it's sitting on a shelf, and it'll probably be there for the next 25 years. because of a pending lawsuit and legal actions that were involved. Nothing that I did, it's just I worked there at the time and dealt with certain things at the time, and so the hardware was picked up for potential use. It wasn't used, but it's stored in some warehouse somewhere for probably the next 25 years. Well, probably 10 now. All right. Yeah, I know it's crazy. It's crazy what some of the things that we're required to do. Yeah, they can. They definitely can. Yeah. They sure make our life challenging at times. All right. Well, that's all I have for today. Just make sure that you get through the introduction discussion threads and the chapter 1 discussion thread, and get your lab access set up. I upload the screenshots to the right, so to the file, right? So so you take a screenshot, put it into a Word document, right? And then you just click on the lab access. And then browse to your computer and upload it. But you just click on the title. Yeah, you can do that with snipping tool and just upload the image, right? Yeah, you can do the PNG file. Yep, you can do that. You meant the lab file, or so you're doing lab 1? Okay. Yeah, as far as that, you don't have to. I just need. Looks like something. Sorry about that. Are you there? Yeah. Okay. Good. Yeah. I had a bad network issue here, and it was kicking me off. Okay. All right. Yeah. But yeah, as far as the lab is concerned, just the PDF questions is all I need. Okay. Great question, though. Upload the photo. Right. So right. So when you get the lab access, right, when you go in, you just get a screenshot and then upload that screenshot. And then I probably don't have it on here. So you would log in, and then just take a screenshot. Yeah, snipping tool is your friend. Yeah, absolutely. Right, and if you haven't used it, right, SN, right, and the snipping tool. and then just do a new, and then just drag, copy it, and then there you go. And you just, file save, and then upload that image. Yeah, snipping tool is a great tool. Right, yeah, yeah. Just, once you're logged in there, just show me that you have access to the lab. Yeah, that's all I need. All right, well, that is all I have today. I'm going to go ahead and stop the recording.